Okay, what do you think was the problem with, or what should I do? Do I have to go over problem one? Do I have to show problem one? There was no need to find the second derivative, so that's all you had to do. Find the first derivative, factor it, and realize that the critical numbers are -2 and 2, so only 2 fits in the -1 to 4. You are given -1 to 4. You cannot change that to -infinity to infinity. This is specifically given to us. So the x and the critical numbers are -2 and 2, but -2 does not fit here, so that's the only one. That's all I needed. Again, I'm going to post this tonight. Okay. Now, problem 2. Do I have to show anything in problem 2? So f of x is continuous. We have to write that. F of x differentiable on -2, 2 as a polynomial function for both. But then there must exist at least one c between -2 and 2 such that this happens. F prime of c equals f of b minus f of a over b minus a. So this was 1. So then 3c squared equals 4. And we get plus or minus 2 the square root of 3 over 3, and which is a number in that. Is this okay? Yes? Okay. Do I have to show problem 3? Anything in 3? A? Yes. So let's do A. And B. Very good. So for A, we have limit as x approaches 0 from the right from sine x times natural log x. And this is 0 multiplied by -infinity. You cannot just simply say this is 0 because I checked with a calculator or something like that. I can't accept that. It happens in this case that 0 times -infinity is 0, but it doesn't happen always. 0 times infinity is an indeterminate case which has to be dealt with accordingly. I can make conclusions till the very end. So I can write this. So in that case, I'm trying to change it into, of course, this is my goal, either this or this. Why would I want to do that?
And you can apply them.
Exactly, exactly. So I'm not going to change anything about natural log. I'm not going to move natural log anywhere. That will be dangerous. So, but I'm going to say this, natural log x divided by 1 over sine x. That I'm allowed to do. Because when I divide natural log by 1 over sine x, I flip sine x and I get this. Now I'm going to change 1 over sine x into cosecant x. So this is limit as x approaches 0 from the right from natural log x over cosecant x. So now the top goes to infinity and 1 over 0 goes to infinity. So now I'm ready for L'Hopital's rule. So this is limit as x approaches 0 from the right. This is 1 over x. And cosecant prime is negative cosecant cotangent. Now, honestly, I don't like this. So I'm going to take it aside and see if I can simplify it a little bit. Because I don't want to deal with a product. Is it wrong? No. All I can do right now, what I should do is just plug in 0. And I see that this is infinity. When I plug in 0, cotangent is cosine over sine, so that's infinity. And this is 1 over sine, so that's another infinity. So this is infinity, but I don't want to differentiate this product if I can avoid it. But I have to take that aside and see what this is. So negative cosecant x times cotangent x is negative 1 over sine x times cosine x divided by sine x. Well, this is nothing else but negative cosine x over sine squared. Nobody forces me to use L'Hopital's rule. Now, I believe this is easier to replace it by limit Sx approaches 0 from the right. There is a minus in there, that's fine. It's 1 over x over this. So 1 over x over negative cosine x over sine squared x. Minus can go outside. Wait for me when I'm done. So when I flip, I get sine squared x over x cosine x. Now I prefer rearranging it. This is no danger. This approaches 1. The danger is sine squared and x, right? So negative limit Sx approaches 0 from the right. I'll change it into sine x over x times sine x over cosine x. I know that this limit when x approaches 0 is definitely 1. I know that this is definitely 1, and I know that this is definitely 0. Therefore, the answer is indeed 0. But I can't conclude because I punch in the calculator and I put in some numbers in there and I got 0. Is it wrong to differentiate this? No, it's not wrong, because now you have 0 over 0. But I don't want to mess with a product. You could have taken cosine out because it's 1, and you could have differentiated 0 over 0 as sine squared over x. That would have been acceptable too. You could have used L'Hopital's rule from here, but it's a little bit more difficult. It looks even uglier, but it's okay too. I accept all those because they're correct. Everything is correct. I have preferred this. Is this clear?
Can you just tell me how sine x over x is 1?
This is what we learned from chapter 2. The limit as x approaches 0 from sine x over x is 1.
Oh, yeah.
Long time ago.
I remember that now. Okay.
Actually, let me refresh your memory since you asked, and thank you for asking. The limit is this. This is how we should remember it. As long as all these pieces are the same. If they are not the same, the limit is not 1. Everything okay so far? Again, here you can stop and just say cosine x approaches 1, and you can take it out. And then you differentiate top and bottom. You will get 2 sine x cosine x over 1, and you will arrive to the same 0. Can we move on to B or not yet? Yes? Any questions on part A? Okay, part B. So we had limit x approaches infinity, e to x plus x raised to 1 over x. Where does e to the x go as x approaches infinity? Perfect. Where does x go as x approaches infinity? I know it's silly. Good. Where does 1 over x go when x approaches infinity? Exactly. So we have infinity raised to 0. This is not a friendly situation. And I have one route, and one route only. And that is, yes. So I have to name this e to the x plus x raised to 1 over x. I have to name it y. Then I have to apply natural log. Natural log y equals 1 over x, natural log e to the x plus x. Now, although this is not what I'm trying to do, I will find the limit as x approaches infinity from natural log y, which is limit as x approaches infinity from natural log e to the x plus x divided by x. I like it. because it's infinity over infinity. And I can apply L'Hopital's rule. So limit as x approaches infinity from, when I differentiate log, I have 1 over e to the x plus x multiplied by e to the x plus 1. When I differentiate the denominator, I get 1. But this is another situation in which I have infinity over infinity. Not a problem, not a difficult situation. Still infinity over infinity. So then I have limit as x approaches infinity from e to the x over e to the x plus 1. I have infinity over infinity again. So this is limit as x approaches infinity from e to the x over e to the x. And now this is no doubt 1. So then I look at the first step and the last step and I put them together so I can see what's needed next. So limit as x approaches infinity from natural log y equals 1. Under certain conditions of continuity, I am allowed to swap the operators. The function goes outside and the limit goes inside. And the function was natural log. I just wanted to remind you the idea. So the natural log of limit, you don't have to write this step, of course, equals 1. And now I'm asking myself, okay, really? So what should this be? And there is only one number that fits this information. Only natural log blah is 1. Natural log 0 doesn't exist. It's negative infinity, right? So careful, careful. Let's graph natural log. Here it is. Natural log as x approaches 0, the function approaches negative infinity. So natural log of is 1. Say it again. Natural log of 1 is not 1. Natural log of 1 is 0. Jane, if you want to enlighten us, you can.
What was the question?
A natural log of what is 1? You're just kidding, guys. So anyone would like to remind us natural log of which number is 1? Ben, save us. E. This must be E. Only natural log E is 1, right? Agreed? So then the conclusion is clear that limit as e to the x plus of e to the x plus x raised to 1 over x is, thank you. Thank you. So I wrote the solutions here. It's all the same thing. Okay, next problem. Do we have any questions on number 4? I saw limits at infinities for f prime. I saw limits at infinities for f double prime. We have never done something like that. There is no need. Yes.
Why is there no
Yes, Ian, go ahead. Say it again.
why is there no vertical asymptote?
What is it?
Why is there no vertical asymptote?
Oh, because 2 the square root of x minus x does not have a horizontal vertical asymptote. It's undefined. It's undefined for negative values, but there is no specific. It's not a ratio. It can have vertical asymptotes. Good. Do we need to look at this, or is that clear? Do we need to work on number 4? Do we need to work on number 5? Yes? Okay. So in number 5, we're given a box it says to make a box with a square base and an open top, and the height is h. Find the largest possible volume of the box. So the surface area of this box is the area of the base, which is x squared, plus 4 sides, 4 base times height. And this is given to us as 1200 centimeters squared. We're asked to find the maximum volume. I have to create a function that is the maximum volume, which is area of the base times the height. So obviously, I want to eliminate the height from here, so I can have a function in x. And I have to solve this equation in which I replace s by 1200 and solve for h. I think we did this problem in class. Yeah. Okay, so 1200, oops, too many zeros. 1200 equals x squared plus 4xh. Subtract x squared and divide by 4x, and that's our h. I plug this in the volume. So now the volume is a function of x, because I have to distribute x squared here. But this is what I recommend. Remember, we said factor simplify. Factor simplify. I will definitely simplify by x before I distribute. So the equation becomes, you can separate this if that's what you want, but I recommend 1200 x minus x cubed divided by 4. Now you can, if you want, negative x cubed over 4 and plus, 300x. If that's what you want to write, it's fine. And of course, I have to find a v prime, which will be negative 3x squared over 4 plus 300. And of course, I have to set it equal to 0. Negative 3x squared equals negative 1200. X squared equals 400. I take the square root, is 20 centimeters. I should write plus or minus, but I can't have plus or minus. So now I have to find the volume of 20. And where is my volume? It's x squared, which is 400, multiplied by h, which is 1200 minus 400 over 4 times 4 is 1600. And let me look and see how much I got here. 4,000 cubic centimeters. However, this is good, but it's not good enough. I have to study the sign. Just plugging in some numbers left and right is not good enough. So x 20 v prime, and I'm looking at v prime. It's a quadratic function with a negative leading coefficient, which means it looks like this. So between the solutions is positive. Between negative 20, which doesn't fit here, and positive 20, it has to be positive, and then negative. And I know that this is local max. Any questions? Everyone did number 6 almost correctly. Almost everyone did it correctly. If you need me to show anything, I will. I don't want you to, on the final exam, I gave full credit, but I don't want you on the final exam to round up anything. So copy, I started with -2. Most of you started with -1, which is fine, perfect. So I had to run through probably more iterations than you did, which is okay too. But I don't want you to round up. So 2, 4, 6. I know you have a 6 and you wrote 58. I gave full credit, but I don't want you to round up. I just want you to show another 2 if you want and say this is it. So I wrote the next one. I realized that 4 digits were the same, so I kept the one that I have from before. No rounding is necessary here. So I stopped at the 3rd iteration because the next one already had the same 6 digits. Okay, and the last one, I would like to talk about it, the extra credit. It had a little trick. Okay. So we're given this function which is L divided by 1 plus A e to negative x over b. And we are told that A, B, and L are constants and they are positive. And find something. So now let's read that something. Verify that the function increases at the maximum rate when blah, blah, blah happens. So this is our f or y, the same thing. Okay. So maximum rate. When we talk about the maximum rate, which function are we specifically talking about? Or let's forget about maximum. When we talk about the function called rate of this one, what function am I talking about? Which function gives the rate? The first derivative. Then I'm asked to find the maximum rate. So if I have a function that is the rate, how do I find the maximum of this new function called rate? What do I have to find for it to find its maximum? I have a function that is called rate, which I know is the first derivative of another function. But I have that function now. Well, we're going to determine it. I have it. How do I determine the maximum of this function? Find the second derivative and set it equal to 0. Because I want not the rate, I want the maximum rate. Okay, now I saw some of you used the quotient rule. I don't recommend it. I recommend changing this function into L multiplied by 1 plus A e to negative x over b raised to negative 1. So then I find f prime of x as being negative L 1 plus A e to negative x over b raised to negative 2 multiplied by the inner function prime. This is 0. This is A times e to negative x over b times negative 1 over b. So let's stop for a moment. So when I differentiate this function, this is a constant. I bring negative 1 in front. I have negative L, blah, 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 raised to negative 1 minus 1 times the inner function prime. 1 is 0. 1 prime is 0. I have A. I have e to u prime, which is e to u times u prime. Is this okay? Is this step okay? I am collecting all the constants in front. So I have negative with negative. So this is L divided by, AL actually, divided by B. So this is accounted for, this is accounted for, this is accounted for. This is e to negative x over b, and this is 1 plus a e to negative x over b to negative 2. If I look at this, which I don't have to write this, there is no need for this, but let's talk about it for a moment. What type of function is this? I mean, to be specific, what is the sign of this function no matter what? Yes, this is squared. There is no discussion there. This is positive. This is positive. This is positive. This is positive. This is definitely positive. So this is a function increasing all the time. But I want to find its maximum. Of course, I'm not going to differentiate this. I'm going to differentiate this and set it equal to 0. And that will give us the maximum rate, or the maximum derivative of the derivative. Okay, so let's find the second derivative. On this, I have to use the product rule. I have AL over B. This prime is e to negative x over b times negative 1 over b times 1 plus a e to negative x over b to negative 2 plus e to negative x over b times this whole derivative. So I differentiate this again, negative 2, 1 plus a e to negative x over b to negative 3 times the inner function prime a e to negative x over b times negative 1 over b. We've done this before a minute ago. Yes, it looks awful, but if you factor it, it's gonna look much nicer. So AL over B. So now, what will I factor from here? Definitely negative 3. 1 plus AE to negative x over b to the negative 3. Of course, I will factor out a negative 1 over b. So this one. I will definitely factor out one of these, an e to negative x over b. And let's see what is left. From here, I factor out negative 3, so negative 2 minus negative 3 is 1. So 1 plus AE to negative x over b. This is gone, this is gone, this is gone. Plus, this is gone, this is gone, this is gone. So minus 2A to negative 2A and one of these. And finally, I have AL over B, 1 plus AE to negative x over b to negative 3. So this b goes in front. I put b squared to make it easier to the eye. And this inside is 1 minus A, 1 minus AE to negative x over b. And when I finally set this equal to 0, let's see what we have. This goes to the denominator, this goes to the denominator, and this is positive. So I have 1 minus a e to negative x over b equals 0, or e to negative x over b equals 1 over a. So when I go back to the original function and I plug this in and I change this into 1 over a, so f of x when e to negative x over b is 1 over a is L over 1 plus 1, which is L over 2. A lot of writing. So I wrote here the max f prime is obtained when f double prime is 0, so it gives this, and if you plug it in, you get what the problem was asking us to do, to find that it's L over 2. Okay. Any questions? Any questions? Any questions? I'm thinking of having sometime next week a half-an-hour test for you in the testing center because there is no time in class if you want to go, and possibly get like 20 points. So if anyone is interested, it's not your case. If anyone is interested, let me know. I will write it and send it to the testing center. You have this week to think about it and let me know. Okay? The same stuff. Not the same problems, though. Yes. You don't need it, but if you want to, that's fine. So let me know at the end of when we meet again next Monday. Okay? So like an extra credit for this test. Okay? Okay, so let's continue with antiderivatives and what they are. We have left section 4.9 and 5 sections in chapter 5 before we start reviewing for the final exam, and we only have 2 weeks left. So actually 4 meetings, and I'm hoping that you're going to meet with me at least one more time so we can make it 5, I hope. Okay, so this section really corresponds to or matches perfectly chapter 5, not chapter 4. So that's why this section will be together with chapter 5 and test 4. Okay, so let's talk about antiderivatives. So we have, first of all, 2 notations, and they are important to understand. if we are given f prime of x, we will be asked to find f of x. So if we are given a function and we are specified that that's a derivative, we will be asked to find the function whose derivative is given to us. And the notation, if this is f prime, this is denoted by f of x. If we are given a function f of x, and we are asked to find the same question, the function whose derivative is f of x, we will be really asked to find, using the notation, the same idea. There is no difference between the two options, no difference, but the notation is different. So if we are given f prime, we will have to use the notation f of x. Even if we are told we are given a derivative, but if the derivative is denoted by f of x, we have to find the antiderivative and denoted by uppercase F. That's our first step. And now, for example, if I'm given a function f of x as x to the 7th, I'm asked to find the most general antiderivative. Which notation will I have to use? Second one. So I have to give this. Perfect. So what do I mean? What do we mean by the most general antiderivative? So let me give you an example. Is the derivative of x squared 2x? Question. Is the derivative of x squared plus 3 2x? Is the derivative of x squared minus 10 2x? So I'm asking you how many functions that you can determine, you can build, construct, will have the derivative 2x. As many as I want, right? Because one of them is x squared derivative 2x, the other one is totally different. It's a different function. Its derivative is still 2x, and I can continue forever. So when we're asked to find the most general antiderivative, we have to have plus a constant c. So now the question is, how do I determine the antiderivative, the simplest possible antiderivative of this? So here is how we determine it. How do I get x to the 7th? Well, by simply differentiating x to the 7 plus 1 over 7 plus 1. In general, x to the n, so this is the derivative, of course. So this is x to n plus 1 over n plus 1 prime. So I bring down the power n plus 1, I simplify it with the bottom of the n plus 1, and I subtract 1 from the power. So that's how I get x to the n. So then what will I have here? What will be the most general antiderivative of x to the 7th then? It's right here. X to the 8th over 8. We bring down 8, we simplify 8, and we get subtract 1 from the power. And this c, it really is taking care of any possible constant, positive, negative, or 0. So that was our first example. Now, how do I determine the antiderivative of the square root of x? So I have f of x is the square root of x. I will change it into x to which power? Very good. So now I can find the antiderivative and the most general antiderivative, which will be x There is no bar here. I don't know why. I'm sorry. I'm going to delete it. 1/2 plus 1 over 1/2 plus 1. By this rule. And of course, if it's the most general antiderivative, I would put c in there. So x to 1/2 plus 1 is 3/2. The denominator is 3/2, and I have to flip the denominator into 2/3. So then I have 2/3 x to 3/2 plus a constant c is the most general antiderivative of f of x, which is the square root of x. And the same way, I would like you to work on this, and let's work on d. It's the same. So the power will be -2. Let's do it because it's a negative power. Let's do it. So then f of x equals 1 over the cube root of x squared. I will change into x to -2/3. By definition, the antiderivative will be denoted by uppercase f. So then I have the same thing, x to -2/3 plus 1 over -2/3 plus 1 plus a constant c. All the same. We need to simplify. -2/3 plus 1 is 1/3, and I flip that, so it's 3 x to 1/3 plus a constant c. I'm sorry, please add this here. I for some reason I forgot to put the f. The x is there, but not the f. I'm sorry. On the next set of problems, we're going to get to it in a minute. I'm sorry, I'll have to correct that. Okay, so if we're given f of x, which is sine x, can anyone give us the most general antiderivative of sine x? So which function prime, which function differentiated, will be sine x? Say it again. Negative cosine. Negative cosine x plus a constant c. Cosine x prime will be negative sine times negative in front will give us sine. Very good. This theorem says that when you find the antiderivative of this, if you have a sum, you just determine the antiderivative of each piece, and you only write a constant once. So that's the theorem for this. So let's start. So let's say h of x. This is 3x to the 4th minus x squared plus 6. We want to find the most general antiderivative of this function, and we will denote it by uppercase h. And so it's 3x raised to the, yes, over 5 minus x raised to the over plus what function prime is 6? Very good. Plus a constant c. Very good. Please choose which one would you like to work on from the next two. They are both the same. But let's choose one. The first one is not multiplied, and this one here I have to multiply first. Here, they are the same. So you want this one or this one? Please choose.
Second one.
Second one, very good. So in second one we have f of x equals the square root of x, 3x plus x to 3/2. These are the expressions that we deal with in intermediate algebra. I teach my students how to distribute, how to change to exponents, and so on and so forth, so they can simplify this. So the square root of x is x to 1/2. So this is 3x plus x to 3/2. I will distribute, of course. 3. Copy the base. 1/2 plus 1 is 3/2 plus x. Copy the base, add the exponents. 4/2 is 2. Only now I'm ready to present the antiderivative of this. So 3 stays outside, and then x to 3/2 plus 1, which is 5/2 over 5/2, plus x to the 3rd over 3 plus a constant c. Let's do this one more time together. So I have to copy 3. Of course, I have to flip to 5th in a second. So 3 gets copied. X to 3/2 plus 2/2, which is 5/2, and I have to copy the number in the denominator, plus x to the 3rd over 3, plus a constant c. I have to write, after I flip to 5th, so I have 6/5 x to 5/2 plus x to the 3rd over 3 plus a constant c. Any questions here?
Six.
3/2 plus 1, which is 2/2. 3/2 plus 2/2. Oh, this one? Oh, I'm sorry. So I have at the top, I have 3/1 over 5/2. I have to copy 3/1, and I have to flip 2/5. And that's how I get 6. I'm sorry. I thought you were talking about this one. Sorry. Is this okay?
So 15.
I'm sorry?
So that's 15. How'd you get 6?
3 times 2 is 6. 1 times 5 is 5. Always multiplication is easier than adding and subtracting fractions. Good. So let's look at the last one in the set. F of theta equals 3 secant squared theta minus 2 cosecant. I'm not sure why I'm swallowing letters. Times cotangent theta. So we want to find f of theta, the most general antiderivative of this function. So what do I write? 3. Which function prime is secant squared? Very good. And then I have negative cosecant cotangent. Which function prime is negative cosecant cotangent? Say it again. No, it's just cosecant, because cosecant prime is negative cosecant cotangent. So plus 2 cosecant theta plus a constant c. Right? So when we differentiate cosecant theta, we get negative cosecant cotangent. Now let's verify. I want to verify my work. I differentiate 3 tangent, and I get 3 secant squared. Then I have positive 2. I differentiate cosecant theta, which is negative cosecant theta cotangent theta. I differentiate c, and I get 0. So I can, from differentiating both sides here, I can get that function back. So there is a family of functions, many functions that have this derivative. Why? Because c can be anything. Okay, now in the next few examples, we are given f prime. So f prime is given to us as f prime equals 4 minus 6x squared. Now we are asked to find f. If we are given f prime or the derivative denoted by f prime, we have to find the function denoted by f of x. So, which function prime is 4? Very good. Minus 6 plus a constant c. Of course, that will simplify, so it's 4x minus 2x cubed plus a constant c. I would prefer writing it in descending order, but that's okay. Any questions so far? Any questions? Now, in the next example, I am told to find f of x, knowing that f prime of x is 4 minus 6x squared, and I am told that f of 1 is 3. So what's different now? I'm given the same function, and I'm asked to find f of x. What do you think this is? And why is it given to us? To find the constant. So this time I will find just one function that complies with the given conditions or fulfills the given conditions. One function, not a family of functions. So then all I have to do is set this equal to 3 when x equals 1. So then 4 minus 2 plus c equals 3. So therefore, how much is c? This is 2 and this is 3. 2 plus what number is 3? 1. So the only function that complies with the given conditions is this. This is not a family of functions. This is just one, specific one, that fulfills the condition that f of 1 is 3. Are we okay with this? Any questions? Okay, so let's look at, this time I'm given the second derivative. 5 times x to 2/3 minus 4 over the cube root of x. And I'm given two conditions now. F prime of 0 is 2, and f of 0 is negative 3. What am I asked to do? The same question. Find f of x. So what do I have to find first? Say it again.
First derivative.
Exactly. Because I'm given the second derivative, I have to go backwards to the first derivative, and then I can go even more backwards, right, to the function. Good. So let's find the first derivative. Can anyone dictate?
First derivative so that would be of x 2
Yes, 5/3. Very good. 2 over 3 plus 3 over 3. Very good. Over. Very good. Excellent. Minus. I will definitely change this one into 4x to negative 1/3. So 4 x raised to, very good, excellent, over, yes, plus c. Very good. Now I will try to simplify it as much as possible. I will flip this into 3/5 and 5 goes away. So this is 3x to 5/3. And I will flip this into 3 over 2. So it's going to be 6, right? Or 12 over 2 if you want. X to 2/3 plus a constant c. I'm given this piece of information. I am told that f prime of 0 is 2. Why is this information given here? to find c. Good. So then 3 times 0 is 0, 6 times 0 is 0, so then c equals 2. So we found the first derivative, which is 3x to 5/3 minus 6x to 2/3 plus 2. We are getting closer, but we're not done, right? We only found the first derivative. What should I do next to find the function? Exact same thing. So 3x2, 5 over 3 plus 3 over 3 is 8 over 3 over 8 over 3 minus 6. X 2 over 3 plus 3 over 3 is 5 over 3 over 5 over 3 plus what? Very good. And plus, I'm going to call it C1, not to be confused with the previous C. If you want to call this one C1 and this one C2, that's fine. If you want to call this one D instead of C, that's fine too. But just make sure that you're not using the same notation. So this is, when I flip 3 over 8, I get 9 over 8, x to 8 over 3, minus 18 over 5, x to 5 over 3, plus 2x plus c1. I am told that f of 0 equals negative 3. So then how much is c1? 0, 0, 0, negative 3. So now I have the one and only function that complies with all those conditions. The second derivative is blah, blah, blah. C, f prime of 0 is 2, and f of 0 is negative 3. And that function is f of x, 9 over 8, x to 8 over 3, minus 18 over 5, x to 5 over 3, plus 2x minus 3. The only function that complies with all three conditions.
What was the X?
I'm sorry?
What was the F? F is 0.
You have it on the handout. Yes. So f prime of 0 is 2 and f of 0 is negative 3. Is that was that the question?
Yeah.
Yes. Okay, sure. A particle is moving with a given velocity and acceleration. Find the position function of the particle, s of t. So the first example is v of t equals 2 sine t plus 3 cosine t, and we are told s of 0 is 0. So I'm given the velocity, I'm asked to find s of t, the distance formula, or the distance function. So what do I do? Which function prime is this? Not the derivative. The antiderivative. Yes. No, it's okay.
That would be
Negative 2 cosine t plus, that's it. So now I'm told that s of 0 is 0. How much is cosine 0? 1. Very good. So negative 2. How much is sine 0? 0. So then plus c equals 0. Therefore, c is 2. So then s of t equals negative 2 cosine t plus 3 sine t plus 2. And this is the formula for the distance function.
for using trig.
Say it again.
I said I prefer using trig than regular numbers.
Uh-huh.
Because you don't have to do with fractions.
True. Here's another example. We are given a of t, which is negative 32. We are given v of t, v of 0, which is 64, and we are given s of 0, which is 6. We're asked to find the same thing, the distance, or the position function.
Based off the equation.
Say it again.
Based off the equation you have.
Yes, that's all I'm given. I'm given the acceleration,